Greetings, we are the Iron Mountain Scope team, and we wanted to start off by giving you just a little bit of an overview of what Iron Mountain is and what they do, in case you might not be familiar. So some of you may not be familiar with Iron Mountain, but you might have seen something that looks like this. This is a box in which papers go, and typically those papers can be anything from health records to employment information to financial information for millions of companies around the world. The question then becomes, what happens to all of these boxes? Losing that information is not a good idea. It's really valuable information, but it takes a lot of closet space to store it. And that's where Iron Mountain comes in. So some of those boxes literally go into a mountain that used to be an iron mine. It is the Iron Mountain, and many go into other places and warehouses around the world, where Iron Mountain commits to securely storing that information and making it retrievable if you need it. However, the scale of this problem is really, really huge. And we aren't talking thousands of boxes, we're talking hundreds of millions of boxes stored with data from all around the world in Iron Mountain facilities today. And while this sounds like an incredibly good thing because the information is stored, there's a problem too, which is this information is in some sense locked away and inaccessible. It can take weeks to retrieve data from one of these boxes, and if that's something like financial records or patient medical records, you really want to be able to access it instantly with the convenience we're used to from computers. Iron Mountain Digital Solutions is their attempt to work on this problem through digitization and scanning, to allow us to digitize the information, put it on the cloud, make it available for data access, and ultimately easy use. Unfortunately, this isn't used for the vast majority of documents that are stored around the world today, simply because of cost. The process of scanning and digitizing documents can be extremely expensive, primarily because when you sweep a pile of papers off a desk and into a box, you don't just get paper. You also get paper clips and staples and post-it notes and the occasional wad of bubble gum, and all of that would seriously mess up a scanning machine. The problem we wanted to work on was asking the question of how we can improve this process of preparing documents to be scanned and eliminate these dead data and this dead data in the world through intelligent automation and process design. I'd like to introduce our team. I'm Eric Miller. This is Lydia Azuso, Jeremy Garcia, Jamie Cho, and Will Thorbeck. And we've been working all year on this problem, both from a design perspective and ultimately from a prototyping perspective. We went through three major phases. We started by trying to just analyze the process as it exists today and really understand what it is that the workers today are doing as they prepare documents. We then went through a design process where we came up with hundreds of ideas and narrowed it down. You've heard this story before. And finally, we spent the second half of the year prototyping and making actual technical solutions to validate some of the claims we were making about our proposed system. So I want to start by talking off a little bit about the analysis we did. So we actually started by visiting an Iron Mountain facility where they perform a large amount of this digitization work. We got to talk to the people who work there, not just the managers, but also the people actually on the ground doing the work every day to understand what their lives were like and what their jobs were. We also got to understand the tools they use, both the big expensive machines, but also the small things, the little things that make a difference every minute of their job. And finally, we got to try doing it ourselves. So this is us actually performing some of this document preparation work and really understanding what the important steps of that process were. To give you a little bit of a better sense, this is a video of one of the preppers we interacted with. We're going to refer to her as Jody. And Jody here is going through a stack of documents and is looking for things that might impede a scanner. So in this case, you can see she's flipping through, she's finding staples, she's finding Post-its, and each time she finds something, she's changing context to switch and deal with that, until you ultimately end up with a stack of clean papers that are ready to be scanned with a high throughput machine. So after all of this analysis, we ended up coming up with a few key design insights. The first was that it turns out most documents that go through this process don't actually need any prep work done at all. There's definitely the edge cases where they do, but lots of them don't really need the dedicated time and attention of a person checking them. That said, there are some that really do. You really do find wads of bubblegum occasionally in these document stacks, and we couldn't imagine any sort of automation solution that will be able to deal with that wide variety of documents. And the other thing, and this one really surprised us, we kind of expected we'd just be making like a staple removing robot or something, but it turns out that the workers doing this today are fantastically good at the actual task of cleaning and preparing documents, way better than even we could imagine a robot being. So to give you a sense of that, I'm going to show you the next slide. This is a different worker we were working with. I'm going to refer to her as Sarah. And what we asked her to do is on the left, her current process, and on the right, we asked her to go through a process where she didn't have to switch context each time. And what we can actually see here is that just given a stack of stapled documents, you know, I've always had to fight with those little claw things to remove a staple. She's way better at it than that. And it was really amazing for us to realize that even this task that seemed repetitive, the people were way better than we could make a machine. And it meant that our task became not how can we replace these people with a machine, but how can we use automation to change the process they work in so they can feel even more productive. And when we talked to Sarah after this test, she actually relayed to us how productive she felt being able to focus on one task at a time and the amount of variety that that could bring to her day-to-day job. So we imagined a new process. We imagined a process where instead of having just one flow of documents that need to be handled individually by a person, the documents are actually split in an automated way into several different tracks. Some of those documents, as we mentioned before, are already clean and ready to be handled, but others need specific types of preparation work done. By putting the human step at those specific points where the different steps need to be done, we can make the human workers both be more productive and feel more productive. In order to enable that, there's sort of an automated system that needs to be built. That includes a reliable sensing piece in order to detect the different kinds of documents that are going through the process and reliably tell which is which. It also requires paper handling, which is actually far harder than you would initially think it to be, just because of the sheer variety we were talking about before. And finally, it requires reliable order preservation. So when you split up the streams of documents like this, you have to make sure they all get back exactly how they're supposed to be at the end of the day, so that the scanned documents come out in the correct order and no information is lost. So we spent the second half of the year working on these key technical problems, trying to understand how difficult they were and what solutions to them could look like. In order to do that, we prototyped at a few different areas. We started by prototyping with a gripper and a mechanical system to be able to reliably pick up pieces of paper. We tested various solutions, and were ultimately able to come up with some concrete proposals about how Iron Mountain should move forward. We also worked on the detection problem, starting with how do you just detect something as simple as a staple? Because, for example, people photocopy staples, and that looks like a staple. And we ended up working with an advanced laser detection system that can actually measure the 3D depth of papers as we go in order to get reliable detections of what is going on with a page. Third, we needed to look at this problem of ordering. And so we worked with a system of cameras in order to detect the ordering of different pages and use individual sheets that we add in order to record that order in the paper stack itself so we could restore it at the end of the process. And finally, we worked hard to build an integrated system using ROS-based software where we could integrate all of these different pieces together into a compelling demonstration of what a final system would look like. We want to give a thank you to our entire liaison team, as well as our faculty advisor and the various advisors here that have helped us. And you can definitely see us at our poster session and ask any questions if you'd like.